Exercise 12.9, question number 1. Find the coordinate of the stationary point on each of the following curve and determine the natural of each of the stationary point. So dy dx will be 2x minus 2. Then the second derivative is 2. So when we have the dy dx equal to 0, then we have 2x minus 2 equal to 0, 2x equal to 2, x equal to 1. So when x equal to 1, y will be 1 square minus 2 times 1 plus 5. So it is 4. So we have the 1, 4 here. And the second derivative when x equal to 1 is 2. This is less than 0. So it is a maximum point. A minimum less than greater than 0. So it is a minimum. So 1, 4 is a minimum. So for this one, okay, instead of using the product rules, I will expand it. Okay, so if I expand this one, this will be 3, 6x minus 3 plus 2x squared minus x. So it's 3, 2x squared plus 5x minus 3. Then 6x squared plus 15x minus 9. Then we will have the dy dx is 12x plus 15. Then we have the second derivative is this is 12x plus 15. It is 12. So when we have the dy dx equal to 0, then we have the 12x plus 15 equal to 0. So this is the 12x plus 15. Okay, so 2x squared, no, 2x squared 6, 15 minus 9. Okay, so we have the 12x equal to negative 15, x equal to negative 15 over 12, that is negative 5 over 4. So the second derivative when x equal to negative 5 over 4 is 12 greater than 0, so it is a minimum point. Since it is a minimum point, so when x is this, then y, when x is negative 5 over 4, y will be 3 times 3 plus negative 5 over 4 times this 2 times negative 5 over 4 minus 1. Okay, so it's 3 times 3 plus x, and then 2x minus 1. CLC negative 5 over 4. So this will be negative 147 over 8. And negative 147 over 8. So we have the negative 5 over 4, negative 147 over 8 is the minimum point. Okay, next, this one, dy dx will be the negative 3x squared plus 12x minus 9. And the second derivative will be negative 6x plus 12. So if we have the dy dx equal to 0, then we have the negative 3xy plus 12x minus 9 equal to 0, or divided by negative 3. Then we will have the x squared minus 4x plus 3 equal to 0. And we do the factorization x1, x3 minus x equal to 1, x equal to 3. So when x equal to 1, y equal to negative 1 plus 6 minus 9. So it is negative 4. And the second derivative will be negative 6 plus 12. It is 6 greater than 0. So it is a minimum. So we have the 1, negative 4 is the minimum point. When x equal to 3, y equal to negative 3 cubed plus 6 times 3 square minus 9 times 3. Okay, so we have the negative x power 3 plus 6x squared minus 9x. So we calculate, we substitute when x equal to 3, then it is 0. Well, it is 0. And then we find the second derivative. So second derivative when x equal to 3 will be negative 6 times 3 plus 12. Then it is negative 6 less than 0. Then it is the maximum point. Okay, so we have the 3, 0 is the maximum point. So altogether, 1, negative 4 is the minimum, and then the 3, 0 is the maximum. So question number 1D. So the dy dx is 2x minus 5, 1, 1. And the second derivative will be 2, wait, this is actually 2x minus 10. So the second derivative will be the 2. So when dy dx equal to 0, 2x minus 10 equal to 0, 2x equal to 10, x equal to 5. So when x equal to 5, y equal to 5 minus 5 squared, that is 0. And the second derivative when x equal to 5 is 2 greater than 0, so it is a minimum point. So 5, 0 is the minimum point. E, the dy dx is 15 minus 12x minus 3x squared. And the second derivative is negative 12 minus 6x. So if we want to have the dy dx equal to 0, so 15 minus 12x minus 3x squared equal to 0. So all divided by negative 3. Then this is x squared plus 4x minus 5 equal to 0. And we do the factorization x1 5 plus 5 minus 1 x equal to 1 x equal to negative 5. So when x equal to 1, y equal to 3 plus 15 minus 6 minus 1, then it is 11. So we have the 111. And the second derivative when x equal to 1 is negative 12 minus 6 is negative 18 less than 0. So it is a maximum. So we have the 111 is the maximum point. When x equal to negative 5, y is 3 plus 15 times negative 5 minus 6 times negative 5 square minus the negative 5 cube. So we have the 3 plus 15x minus 6x squared minus x cubed. So when we substitute with negative 5, it is negative 97. So negative 97. So the second derivative when x equal to negative 5 will be negative 2 minus 6 times negative 5. So it will be 30 then 18 greater than 0. So it is the minimum point. So the negative 5, negative 97 is the minimum point. Okay. So and the dy dx is 1 minus 2x. And the second derivative will negative 2. So if we have dy dx equal to 0, 1 minus 2x equal to 0, 2x equal to 1, x equal to half. So when x equal to half, y is 3 plus half minus half squared. Okay, then this is 3 and 1 over 4. Okay, mm, or 13 over 4. Okay, and the second derivative when x equal to half is negative 2 less than 0, it is a maximum point. So we have the half 13 over 4 is the maximum point. Okay, that